Okay, yeah, so let's welcome to our class. And today we're going to continue our lecture for lesson 18. So we had a talk about halfway there in our lecture, and let's just quickly look at what we have learned. So essentially, we trying to create a program ourselves, which is to mimic the find command in the Linux system, right? And in this find or fsize program, what did that do is it is to list all the file and all the subdirectory inside it iteratively, right? So we kind of go through all the functions. The most challenging function is this directory, because it has to get inside the directory and go through every item inside of it, determine if its name is too long, or if it cannot be open, or it's running out of the slot. Then we do, or it is like a parent directory or self directory, and then append the file name after the directory, right? This is the most complicated part. We kind of talk about it, but today I will kind of give you another way to look at it. So hopefully that will make a better sense. So let's look at this scenario, all right? So we have talked about this so far last time. Now I have added this slide. So if you have copied my slides, you have to copy it again. I have updated a little bit. Let's imagine this is a scenario, right? So we have a parent folder, which is called home user. Underneath this folder, we have two file 1 and 2. And then we have a directory called subdirectory 1. And inside this subdirectory, we have another file, another subdirectory, and underneath we have another file, all right? Just to make up a directory scenario which complicated enough. We will not necessarily use all of them in our example. So now let's look at how our directory function works. So we passed, first of all, we passed this directory name, right? The name is home/user. The reason we send that in is because the type of it is directory, right? We talked about that before in the main function. So then we have a pointer, which is nbp, which is name buffer pointer, right? That will pointing at the end of this name, because we're going to append the file name underneath behind it, right? So our pointer is being moved to the end of the position, and then we add a slash at the end of it. So now our name is like this, like has the slash behind it, and it's the pointer is pointing at one position after this slash. Does that make sense so far? Right. So if we look at our code, you can see we have our pointer, right? The pointer is pointing at the name plus the length of name, right? So that means it's pointing at the beginning of the name, then you move to the end of it, right? And then you append this slash to the directory name, right? Okay, so then we just open it up, right? So if it doesn't work, it will return. But if, let's say it works, it open it up. Then we use a while loop to read each of the directory entry. So this is how the directory entry could be localized. So you can see here, like it's going through so-called slot, which doesn't necessarily means all the file there's some empty slot. Imagine like at the beginning you create a file 1 and a file 1.5, and later on you have deleted. So this slot is being emptied out. So when we are using this read command, it's reading using this file descriptor, right? The describer is the directory, it's from the directory. And then it will start from the slot 1 and it's trying to find if this is a file there. And then because this is a while loop, the next iteration you run it here, you might encounter sometimes some unused slot. In that case, we just passed it essentially. Note here, every slot will have an index node number and a file name. So whenever the inode number is 0, means the slot is unused. That's how we determine it, if this slot need to be skipped or not. Yeah, so we skip the slot with the DIO as 0. We also skip the current directory as well as the parent directory. Okay, let's say now we find our first file, right? Now our goal here is to append this file name after our main name, right? Which is the file user slash. So we'll add it at the end of it. So in that case, we'll use another pointer. Okay, this is an EP, because we're inserting the character of the file name one at a time. So after you have done inserting, your pointer is pointing at somewhere after this letter T here, right? So that is, once it's there, this pointer is like useless essentially, because for the next file, we're going to restart from this point, right? So that's why we make a copy. Like originally we have NBP, we make a copy of it. We created the copy as NEP, and we use that pointer to add the character one after another, and essentially the NEP reach over to here. Then we add the end new terminator at the end. So that's it. Then this pointer is useless. We just throw that away. And next iteration, we have our NBP pointing here still, right? Then we make another copy from it as an EP and insert another file name afterwards, right? So this makes things very convenient while we adding the file name to the name string. All right, so then we call our fsize function, and again on this file name. This file path. So that will go to the next iteration of iteratory of that, right? So that is fine. The last part, well, not necessarily last part. Well, one interesting operation I want to point out is once we have processed everything inside this directory, we're going to move this pointer backwards by one position and add the new terminator to it. So that is essentially remove this slash as well as anything afterwards, right? Because you might already append a bunch of file name after that. So we just go, our pointer is still there. There's a bunch of other things underneath. You don't worry about it. Then you move it backwards and add a new terminator here. So then next time, if you're reading the name, it's just home/user. That's it. So for the next round of operation, right? So this is called the name restore. Yeah, so this, we kind of using that example to help you understand how the function works, and this will be due through multiple iterations. So every time we encounter a directory, we will call this process again and again, right? Recursively. All right, so that's the essential idea of this function. Hopefully this make a little bit better sense. If we look at the main logic, first of all, we're adding a slash to the end of the name, right? And then we read through every entry in the directory. We skipped unused slot, skip the self directory, skip the parent directory. Then we append the file name to this basic base directory to create a full path, and then send it to another fsize function. And then lastly, we restore the base path, right? Just so we can get back our original directory name, right? Just yeah, so we can go another entry afterwards. All right, sounds good. So for the first part of this lesson 18, we have talked about this fsize function, which is using that as an example to talk about how the Unix system are operating the file systems. All right, so the next part of the lesson, we're going to look at the allocate, memory allocate function. We kind of use them as a default function before. Now we want to create both of them ourselves, so we knowing a better idea of how the Unix system works. To use this allocate and free function, we're going to use the knowledge we learned previously. One is structure, one is union, the other is type definitions. Anyone can still remember what is union mean? No idea? Any guess? No. Let's shake hand. Okay. Okay, we'll look at it in a little bit. So when we talk about allocating memory space, you can think that it is a chain of free block. Okay. Anyone can tell me what is block means? Yeah, something like that. Yes. So if you didn't hear it online, so we're saying we could set up a size like 512 is a 512 byte is a one block, right? And then we every time we read it or write, we will just operating on the block level, right? That could be one use of this size of block. And in different system, in different machine, the block size could be different. But the essential idea is we're not writing one byte at a time, right? We read or write one block at a time. So for
space that's sharing different kind of element that's sharing the same block of space, and it will be at the maximum of the value, the maximum of the font of the value that is inside it.
Great. Yeah, that's right. So I just asked about what does union mean. So union is we can call it a special structure, right? It has different type of variables underneath, and the size of the union structure is decided by the biggest one inside of it, right? So it can contain one of those. Like let's say you have 3 type of variables inside of it. It can be any one of those things. All right. So let's look at the block a little bit using an example in our Excel sheet again. So let me change my screen sharing setting to the full screen, entire screen. Okay. So let's just imagine like this is our memory space, right? Like every block is memory space. And just for simplification purpose, let's say we will take every 4 cell as one block. Well, block is just a bunch of memory space. You decide the size, which makes sense to the system, obviously. But we, for illustration purpose, let's say this is one block, all right? So that's essentially the minimum size we want for the block, and well, that's the maximum one as well. All right. So when we talk about the in the slides, we talk about we using a fixed size, sorry, a chain of free block, right? So we have a chain of free block means, so in the memory, let's say we have this part, which is free. Okay, so I will just mark it as green. Okay, they are free. And then later on, we have I would say this space, oh, come on, is also free, right? And then later on, I have this space is also free. Well, if we just look at this way, right? And you can see it should be minimum 1 block. It could have 2 block or 5 block. Longer, that's fine, but not less than that, right? So in each block, okay, in each block, we will have a header which is contains the information like this. Like one is the size of the block and the pointer of the next block, as well as how much free space it has inside the block, right? Because you can use only part of the space inside your block, right? Also, those information, the size, pointer, the free space itself, they are also stored inside your block as well, right? So the first cell in every block is always used for the header purpose. Only the remaining block can be used for storing data, right? So now we have a little bit challenge here. Actually, before we